Hello, this is Mr. Stansbury. I'm going to take you through the 15E assignment. All right, so number one is in the following implicative statements, state the antecedent and the consequent. Okay, so we're going to make this easy. We're going to underline the antecedent in blue, and then we're going to underline the consequent in red. All right, so for the first one, the antecedent, again, this is the if portion of the statement. So an integer ends in 0 or 5 is going to be the antecedent, and then it is divisible by 5 would be the consequent. And you really could put the integer is divisible by 5 would be the consequent. Okay, so that's the then. All right, for B, the temperature is low enough is the antecedent, and then the then part, or the consequent, it would be then the lake will freeze. Okay? Actually, you don't even need then. Let's just put just the lake will freeze. Okay? Next one, C. If 2x plus 5 equals 17, so it's just 2x plus 5 equals 17, then we get 2x equals 12. So that's the antecedent and the consequent. Okay? Q. Write down the conditional statement P implies Q. Okay, so if you'll remember, this is if P, then Q. Right? And then state where the conditional statement is true or false. Okay, so for A, we write down the conditional statement. So if 17 is greater than 10, then 17 plus 3 will be greater than 10 plus 3. All right, and part 2 says state where the conditional statement is true or false. That would be true, right? Because 17 is greater than 10, and then so 20 is greater than 13, so that would be true. All right, B. Let's see, if x is greater than 4, then x squared is greater than 16. Okay, so that's our that's the conditional statement. If then, so then let's see, if x is greater than 4, then x squared is greater than 16. So this should also be true, right? Because any number that's greater than 4, when you square it, will be greater than 16. Along. Number 3, suppose P represents it is raining and Q represents there are puddles forming. Write the following statements in symbols. All right, so P is the raining one, and then Q is the puddles. Okay, so if it is raining, so we've got if it's raining, so that's P, then puddles are forming. So the conditional, the if then, remember, is the arrow. So P implies Q. If P, then Q is what that reads as. Okay? B, if puddles are forming, then it's raining. So now it's the other way around. So Q, if Q, then P, right? So that would be B. C, puddles are not forming, so that's Q. So if it's puddles are not forming, we'd have to go with not Q. All right, and then D, it's not raining, so that would be not P. Okay, next one, construct truth tables for all of these implications. So again, let's go with P and Q. So this is true, false, false. And then we've got true, true, false, false. Okay, I don't see any R's in here, so we should just need these two. So for A, we've got P implies not Q. So let's do this. We've got not P and not Q, so let's do not P in here because we're going to need that at some point, and not Q, we're also going to need that one. So not P is false, false, true, true. Not Q is false, true, false, true. So for A, we've got P implies not Q. Okay, so It's important to remember on this one with implication, the only way that this is going to be true, the only way it's going to be false is if you have, if you remember back to the cookie thing, if you have the ingredients and you make the world's best cookies. So if the only thing that's going to make this thing false is if true, we have the ingredients, and then false, we can't make the world's best cookies. Okay, so if you remember that from the notes, true for the first one, for the antecedent, and then F for the consequent. So for the first, the if has to be true, and the then has to be false is the only way to make it false. Okay, so P implies not Q here. We're not gonna have enough colors, but we'll go with this. So P implies not Q. So this one, it's important that the order is correct. So we got to start with P. So you have the ingredients, you make the world's worst cookies, so that would be false. Okay, you have the ingredients and you make great cookies, that would be true. You don't have the ingredients, you can't, it doesn't even matter what this is over here because you can't disprove if you don't have the if part of the statement. So you have to assume that that's true. And again, we don't have the ingredients, so you have to assume that that's true. Okay, so that's A. All right, B, we've got not Q implies not P. So we've got not Q. Let me do this just so we can try to make this as easy as possible. So let's see, we're going to do this in red. So we're going from, let's see, B. We've got not Q implies not P. Okay, so not Q is first, and then not P is second. Okay, so we got to go from this to that. So if we don't have the ingredients, you have to assume that they can make the best cookies. If you have the ingredients and you make awful cookies, that's our one case when it's false. Don't have the ingredients, so you have to assume it's true. Have the ingredients and you make the best cookies, so that would also be true. Okay? Okay. Hopefully this is starting to make a little bit of sense. I know this gets a little weird, but once it starts clicking, then we're in good shape. So C, we're going to do P and Q. We don't have that yet, so let's figure that out first. So C will actually end up being over here. Okay, so P and Q, just these two together, so they have to both be true. So the first one is true. True false is false. False true is false. And false false is false. Okay, so now we're going to be able to do part C, which is P and Q. Implies P. All right, so what we need to do there is, again, I'm going to get rid of these numbers here, and then let's put in our new ones. So we got P and Q, so this is the first part, and then implies P, so that's going to be the second part. So this is the if, that's the then. Okay, so if you have the ingredients and you make the world's best cookies, that's true. If you don't have the ingredients, you have to assume they can make it. Don't have the ingredients, don't have the ingredients, so all of those are going to be true for C. Okay? All right, let's move on to D then. Oops, and that's Q and P implies Q. We have not done P implies Q, so let's do that first. Let's see, I gotta pick a different color here. I guess I really don't have to, do I? I'm just gonna pick green here. So let's do P implies Q right here first. Okay, so again, I'm gonna get rid of our old numbers so we can put our new ones in there. So P is first, and then Q is second. So P implies Q. So have the ingredients make the best cookies. That's true. Have the ingredients make awful cookies. That's false. Don't have the ingredients. You have to assume that it's true. If you don't have the ingredients, you have to assume that it's true. Okay, so that's just our P implies Q. Now we have to know Q and P implies Q is the next one here. Okay, So let's see. Let's put our new if-then pieces up here. So we've got Q implies P. Sorry, Q and P. Did I do this right? Let's see. Where did I get this from? Q and... Oh, I just forgot the parentheses. There we go. P implies Q, so that's the second part. And then Q is the first part. Okay? So, Q... Oh, but this is just and, so it doesn't matter what order it goes in. So, but we do have Q and P implies Q. So we've got true and true. So since it's and, that's true. False and false is false. True and true is true. False and true is false since it's and. Okay, so that was D. And that would be number 6. Which of these forms are logically equivalent to the negation of Q implies P? All right, if we want to know the negation of Q implies P, we first got to figure out what Q implies P is. So let's start with P and Q. True, false, true, false, true, true, false, false. So the first thing we want to come up with is Q implies P. So that's Q is first, P is second. So you have the ingredients make the best cookies. That's true. You don't have to have the ingredients, so you have to assume that it's true. You have the ingredients, you make terrible cookies. You have disproven your claim to making the world's best cookies. And if you don't have the ingredients, you have to assume that the claim is true. Okay, so there's Q implies P. So, but now they're asking which of these forms are logically equivalent to the negation of Q implies P. So we have to do the negation of Q implies P. Okay, whoa, me and my straight lines. There we go. So that's basically just going to be the opposite of this. So true now becomes false, true is false, false is true, and true becomes false. So this is what we are going to be comparing all the rest of these to, right? Okay, so this is what we want to compare all of A through D to. Okay, so let's do this. A. P implies Q. Okay, so if we're doing that there, let's get rid of these. And P is first and Q is second, right? So you have the ingredients, you make the best cookies, that's true. Have the ingredients, make awful cookies, that's false. Don't have the ingredients, so you have to assume it's true. Don't have the ingredients, you have to assume it's true. So there's P implies Q. Is this the exact same as that? Not really even close. So the first one is A is going to be no, it's not logically equivalent. Okay, so let's do B. We got not Q. So the first thing we need is not Q, because we don't have that one yet. So Q is true, false, true, false. So that's going to be false, true, false, true. So we got to have not Q implies P. Okay, so let's, since this is implication, the order matters, so let's put our order up here. So not Q is first, P is second. So you do not have the ingredients, so you have to assume they're telling the truth. You have the ingredients and make the best cookies, that is true. You do not have the ingredients, so again you have to assume they're telling the truth. You have the ingredients and make the world's worst cookies, that is false. So not Q implies P, false, false, true, false. We've got true, 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 false, so that is also not logically equivalent. All right, number 7 here. If a logical form has a truth value which is always F, that's called a logical contradiction. If the truth values are always T, it's called a tautology. Which of the following are logical contradictions and which are tautologies? And they may be neither if there's a combination of trues and falses. So P's and Q's are all we have. So let's start with P and Q. True, false, true, false, and this is true, true, false, false. Okay? So, let's see. We have a not P and a not Q in here, so let's do not P and not Q, just to kind of cut to the chase for later. So, P is true, true, false, false, so not P is going to be false, false, true, true. And then Q is true, false, so that would be false, true, true. Okay, so for A, we're going to first do not P and Q. Okay, so here's not P, here's Q. They're and, so we just have to figure out if they're both true or not. So we got true, false, which would be false. False, false is false. True, true is the one case when it is true, and then false, true is false. Okay, so there's this piece. So now we have to come up with P implies not P and Q. Okay, so this is going to be A here. All right. So let's see, P is first, and then not P and Q is the second part. That's the then piece. Okay, so you have the ingredients and you make the world's worst cookies. That's our one case for false. Have the ingredients, make the world's worst cookies. False. If you don't have the ingredients, you have to assume that it's true. If you don't have the ingredients, you have to assume that it's true. So false, false, true, true. This would be neither. It's neither a logical contradiction or a tautology. Okay, again, if they're all falses, logical contradiction. If they're all true, then that's a tautology. Right, let's move on to let's see. So that was A. Let's move on to B. So first thing we need for B is P and Q. Okay, so let's see. P and Q is just these two, right? P and Q. So again, they have to both be true. So we got true, true. That's true. True, false is false. False, true is false. And false, false is false. So we got to know if that implies. So if P and Q implies P or Q. So we need now P or Q. Okay, so it's the same two. Now it's or. As long as one of them is true, then it's true. So true, true is true. True, false is also true since it's or. False, true is true. And false, false is false. Okay? So now what we have to do is we have to, for part B, we have to say P and Q. Does that imply P or Q? Okay, so that makes this P and Q is 1, P or Q is 2. Two. So if you have the ingredients to make the world's best cookies, that's true. If you don't have the ingredients, you have to assume that it's true. Don't have the ingredients, assume it's true. Don't have the ingredients, assume that it's true. So this one is a tautology because everything is true. Okay?